All right, let's talk about exponential functions. We're going to take some notes. Please label your paper exponential functions at the top and make sure you put this in your table of contents also. So we're going to need you to identify two different things today. First, we're going to talk about the graphs, and then we're going to talk about the actual functions. So you'll need to be able to identify both as being exponential growth or exponential decay. This is the graph of exponential growth. You can just see as you walk to the right on this graph, you can think about your money going up and up and up, so you're going to have a lot of money to spend in your retirement. Now this is exponential decay, and for those poor souls that have huge credit card debt, this is the amount of money you have in your bank accounts going down, down, down as the months go by. So exponential decay. They have a very unique curve to both of them, so please remember. Growth, decay. Growth, decay. Hopefully we got that. Now let's talk about the actual function. We have f of x equals 30 times 1 plus 0.2, and that is all raised to the power of x. Now, the x is your input. The f of x is your output. The 30 is your initial value. So that's your initial value. Now, your growth factor is everything in the parentheses. It's the 1 plus the 0.2. So the 1 represents the initial amount you started with. The 0.2 is the amount you're growing by. When you add that 1 plus the 0.2, you get the growth factor. And sometimes it'll just be a number there. I could have written it just 1.2, and you would have had to put the plus sign in your head. More importantly, that 0.2 is the growth rate. So if this is your money in a bank account, every year it's growing by 0.2 or 20%. So when you look at these, you need to understand what the initial value is and whether it's growth or exponential decay. So let's look at a couple of examples. So you're looking at f of x here. Now, is this growth or decay? You have an initial amount of 20. There's your initial amount. Now, if your growth factor is between 0 and 1, so you're going to be growing, you're going to be decaying exponentially. So this is 1 minus 0.09. So that's going to be less than 1. So that's exponential decay. If you look at g of x, your initial amount is 341. Now here, your number is more than 1, so your exponential growth. And then if you could tell me what your growth rate is, that'd be totally awesome. So your growth rate here is 0.11, which would be 11%. Next, we have h of x. Now, is this exponential growth? Or is it exponential decay? And how much did you start with? What's your initial value? So your initial value is the 83. Now this growth factor is 1 plus 0.33. So this is exponential growth. Now bonus question, what's the growth rate? The growth rate is that 0.33 or 33%. So if your money is growing at 33% a year, you're doing pretty well financially. Now let's look at I of x. This is 140 times 1/4 raised to the power of x. Now is this exponential growth or exponential decay? Well, 1/4 is a lot less than 1, so you are decaying. So this is exponential decay. Another way to kind of think about this, I could have written it with the minus sign. The minus sign kind of tells you it's going to be decay. 1 minus 3/4 is going to be that 1/4. So just an alternate way of writing it out. And finally, Just because you see a fraction for your growth rate, don't automatically think that it's exponential decay. Now, on this one, is the fraction greater than 1 or less than 1? Well, you might have taken my previous hint and figured out that 5/4 is greater than 1. If I wrote that as a decimal, it would be 1.25 or 1 plus 0.25. Bonus question, what is the growth rate? The growth rate here is 0.25 or 25%. Alrighty, so can you identify the graph of exponential growth versus the graph of exponential decay? And if I give you a function like j of x, can you determine whether it's exponential growth or exponential decay? Can you determine the growth or decay rate? And do you know what the initial value is? If you can answer those, you're going to do well in the next test. Thank you very much.